Distributed ledger technology for business applications. In this lecture, I'll talk about the characteristics that are desired in a distributed ledger technology for creating business applications. At the end of this lecture, you will understand at a high level why Hyperledger Fabric is suitable for creating distributed ledger technology based business applications. Hyperledger Fabric is a distributed ledger technology for the business. The key word here is the business that differentiate the Hyperledger Fabric from other blockchain technologies that are geared more toward the public domain. Two such dominant public domain distributed technology networks are the Ethereum and the Bitcoin networks. Business application would require the distributed ledger system to have certain characteristics, which may be different from the characteristics desired in a public domain distributed ledger technology. There are four characteristics that makes Hyperledger Fabric suitable for implementing DLT-based business applications. Hyperledger Fabric is a permissioned network. It supports confidential transactions, and to participate, one does not need cryptocurrency. And it is programmable. With these characteristics, Hyperledger Fabric establishes trust, transparency, and accountability among the participants in the network. Hyperledger Fabric allows businesses to create permission network. The Hyperledger Fabric provides ways by which owners of the network can restrict who can access and do what on the network. It requires participants in the network to be known. And to join the network, the participants have to get permissions from some authority. Compare this with the public DLT platforms such as Ethereum, where anyone can participate on the network as it is a permission-less network. Hyperledger Fabric provides ways by which the roles are assigned to the participant and actions that can be taken by each of those roles are restricted by way of access control list. Transactions are validated by a known set of validators that the participants trust. Since all participants are known in a business setting, it is easy to identify or establish those trust authorities or transaction validators. Compare this with a public network where everyone is anonymous and there is lack of trust among the participant. That is why in those public networks such as Ethereum, resource-intensive validation schemes are used. Another characteristic that is desired for business applications is the confidentiality of the transactions. Not all transactions are desired by the business to be visible to all. Hyperledger Fabric puts participants in control of the visibility of their transactions. Consider the scenario where A, B, and C are engaged in carrying out business on a DLT-based application. So any transaction initiated by any of these entities will be visible to all of these participants. Now, if B and C would like to engage in some kind of business activity that requires them to restrict the visibility of the transaction to only two of them, then they can create a private channel to carry out such business. Any transaction initiated by B or C on this private channel will be visible only to B and C. Business using Hyperledger Fabric can create and participate on multiple such private channels or networks. Hyperledger Fabric does not have any concept of cryptocurrencies. Let me explain to you why it's not needed by comparing it with the public distributed ledger platforms such as Ethereum. Now, Ethereum uses cryptocurrency to incentivize the distributed ledger network. Transactions on Ethereum are validated by miners who get paid in cryptocurrencies that they can exchange for the fiat currency. This kind of transaction validation scheme is not needed in case of a business DLT application. In other words, there is no need to incentivize the network using cryptocurrencies. Hyperledger Fabric allows participants to decide on who the validators would be and what kind of policies will be used for transaction validation. Typical public domain transaction validation schemes such as proof of work, which is very resource intensive, is not applicable and is not needed for distributed ledger business applications. Hyperledger Fabric is programmable by way of the construct called the chain code. Conceptually, chain code is the same as the smart contract on other distributed ledger technologies. Businesses can use the chain code to automate the business processes. Chain code sits next to the ledger, and participants of the network can execute the chain code in the context of a transaction that gets recorded in the ledger. Automation of business process by way of chain code leads to higher efficiency, transparency, and greater trust among the participants. Let's summarize. There are four characteristics that make Hyperledger Fabric ideal for building distributed ledger-based business applications. Hyperledger Fabric allows participants to create permissioned distributed ledger technology-based business applications. Participants may leverage the private channels for managing confidentiality of the transactions. That is, transaction visibility is restricted to select parties in the network. Now, unlike public networks, Hyperledger Fabric business applications do not require mining and expensive computations for transaction validation. There is no concept of cryptocurrency in Hyperledger Fabric. The chain code construct available on Hyperledger Fabric can be used for automation of the business processes and for building business logic. The chain code is conceptually the same as the smart contract on other distributed ledger technology platforms. Hyperledger concepts. In this lecture, I'll cover assets, chain code, and ledger. At the end of this lecture, you should be able to explain the relationship between assets, chain code, and ledger. As discussed in the lecture on distributed ledgers, assets represent some kind of value that can be exchanged on the blockchain systems. Any object of value in the real world may be represented as an asset on Hyperledger Fabric, as long as it can be represented digitally. On Hyperledger Fabric, the asset representation may be JSON or in binary format. For example, a simplified representation of the car will have two attributes in the JSON representation: the VIN number field that uniquely identifies the car and the owner of the car. This second field, that is the owner, can change as a result of a sale of the car. In effect, we are saying that the state of the asset may change over time. These state changes can take place on Hyperledger Fabric only by way of well-defined transactions that are coded in chain code. Chain code defines the structure of the asset. It also defines the transactions that can be executed against the asset. It has all of the business logic needed for the transaction. In the case of the example of a car, there can be a function sell the car defined in the chain code, and call to this function will lead to the transfer of ownership of specific car to the new owner. All transactions are recorded in a ledger. Ledger is a data structure that keeps track of all of these transactions. It also records the state changes taking place in the assets as a result of execution of these transactions. And you already know that the ledger in Hyperledger Fabric is distributed. That is, all participants have a replica or copy of the ledger. Let's summarize. In this lecture, I introduce you to the concept of assets, chain code, and ledger. Assets represent anything of value in the physical world. Chain code is used for defining the structure of the asset, which can be binary or JSON representation. Chain code is also used for coding the transactions that can be executed against the assets. When the chain code is executed, it leads to the addition of the transaction information in the ledger. Ledger also keep track of the state of the asset. Hyperledger concepts. Fabric is a permission network. What that means is that there is a need to assign identities to the participants in the network. In this lecture, at a high level, you will learn about how the identities are created and managed on Hyperledger Fabric by way of membership service provider component. Businesses deal with known entities. Businesses have B2B partners, for example, suppliers of raw material or purchaser of goods. In some industries, by law, businesses are supposed to interact with only known entities. For example, banking industry. Banks must know the identity of every single customer it has. Then there are regulatory agencies that interact with the businesses. A distributed ledger technology based application for businesses, in effect, would require support for managing identities on the distributed ledger network. Now you have already learned that Hyperledger Fabric supports permission blockchain networks. Let's go a little deeper into what it means. It means that unlike public networks such as Ethereum, anonymous access to blockchain applications built on Hyperledger is not allowed. Business application defines the roles that are assigned to the participant, and access is granted or restricted by way of these roles. An abstract service, referred to as the membership service provider, takes care of generating the credentials for the various participants. More on this service in a little while. Let's define the term member. In the context of Hyperledger, a member refers to a legally separate or independent entity. Here, A, B, and C are legally separate and hence defined as the members of the blockchain network. In case of our car example, these three entities may be the car manufacturer, the car dealer, and the repair shop, each of which are legally independent entities. Identities in the Hyperledger network are managed by way of X509 certificates. When a participant identity is created, the certificate is issued to the participant. Anytime a transaction is initiated by the participant, certificate's private key is used for signing the transaction, and any component in the network can validate the authenticity of the transaction by using the participant's public key. Interestingly, on Hyperledger, it is not only the participants that are issued the certificate, even the infrastructure components are assigned an identity by way of certificates. This is to prevent a scenario where hackers can add a server to the network, for example, to disrupt the network or to make an attempt to manipulate the transactions. In effect, every single infrastructure component in the Hyperledger network must have a valid certificate to become part of the network. Members are the legally separate entities, and so even they are assigned an identity by way of a certificate. Certificates follow the typical process of issuance and revocation by the certification authorities in the network. Members can manage the identities within their organization. This aspect will remove the dependency on a single centralized certification authority, and this is achieved by way of implementing the concept of membership service providers, where the member can use their certificate to create new valid identities that can participate on the network. So in other words, member can create new participant certificates that associate the participants with the organization or the member by virtue of the certificate chain. Also, member can create the certificate for their infrastructure component. As a result, the Hyperledger Fabric network can have one or more membership service provider components. Hyperledger is a permission network. All entities participating on the network are known and have an identity which is assigned by way of X509 certificates. Certificates are issued to all participants, infrastructure components, and members. Members are legally separate entities. These are the organizations that have decided to adopt blockchain for process automation. Each of these members are assigned a certificate, and depending on their authority, they may be able to use an MSP to create participant and infrastructure component identities within their organization. A blockchain network can have one or more MSPs, as shown in this illustration.